Hey everyone, this will be our solution video for quiz 7. So first of all, I've already made the key out and made a few notations on it. We actually started recording this video once already. So let's get right into it. So what's this problem about? Number one, this is a given half-life and initial condition. So this problem goes given half-life and initial amount, solve for t corresponding to 100 milligrams. Yep. So that's our goal. Yeah, and how are we going to do that? Well, we're going to use a formula. If capital T is my half-life, then my decay factor is 1/2 to the 1/t power. Okay, so what else do I need to know? Well, my C is given. C is 500 milligrams. And you see here, I've skipped a couple steps of algebra, but I started off with, this would be like my step 1. Just wrote it down, right? What T makes Ca to the power of T equal 100 milligrams? Well, it starts off 500 milligrams times 0.87 to the T. And we'll divide both sides by 500 milligrams. You see that right here. And we end up with 1/5 from that. Using the rainbow rule and dividing both sides by log of 0.87, we get this expression. And that's basically the solution. Let me hop over to Desmos and kind of show you some tricks and tips for this guy. So, well, as I said in the Getting Started with Desmos video, let me turn off these graphs. That's a little too busy, don't you think? Isn't that amazing? On, off, on, off. It's like 6 buttons to do that in TI. Well, maybe 3. Anyway, yeah. So I mentioned that we can just use the general form. We can write the general form of an equation straight into Desmos. I can use capital letters and lowercase letters, just like we might. Now, how do I get that power up there? How do I get that to the T power? Well, if I wanted it squared, I could hit the squared button, but that's not quite what I'm looking for. Instead, I'm going to hit this A to the B button, and that just pops you up into the exponent. You can write anything you want there. I'm going to write T. Now, Desmos is detecting that I've written a bunch of gibberish, that it doesn't know what C is, it doesn't know what A is, it doesn't even know that T is supposed to be a variable. Well, first of all, let's finish this off. Let's like make it an equation, right? Yeah, okay. Well, it still doesn't know T is the variable. So let's give it a little help. What was capital C? That was equal to 500, no? Yeah. And let's see, what was A equal again? A was equal to parentheses 1 divided by 2, close parentheses. Use that A to the B button again. To the 1 divided by cap T for half-life, right? Oh, wait, but I didn't tell it what T was. Oh, that's okay. That's okay. Because what was cap T? That was equal to 5 hours. And look, there's our 0.87 again. And now, if we zoom out properly, it is plotting our curve for us. Yep, there it is. See, if I click on the curve, it even shows you which curve you're plotting there. So, given Desmos a couple clues, hey, A is this number, C is that number, T, well, A is a function of capital T, it can finally start to realize, oh, this is an output input is t, output is y kind of situation. And if you use y, Desmos is generally happier. Desmos likes y for outputs. It's not unlike us that way. Okay, so that's basically what's going on here. I could solve this graphically from here. I could say, when does y equal 100? 1,000? 100. And look at this. I can click on that intersection and it says 11.61 hours. I believe that's what we got in our solution. But there's another way to get there, right? The formula for a certain t is always going to be, or you can always write it as natural log of the target value, the target y, divided by our initial value, which is cap c. Cap c is 100, right? Ooh, that's a negative number. Is that a problem? No, not yet, because we're still dividing by the natural log of a. Boom, 11.6. Just like the crossing graphs method taught us. Yep. They're rounding to 1 decimal place there. I believe you can change that up here if you'd like. Just to emphasize again, if you're using this for a trig calculator, there's your degree mode. Okay, so that's the basic format. Let's look at the other problems. Hey, this one's just solving for a different particular value, right? So if I hop over into my quick formula calculator that I've made in Desmos, right, and saved it, I'll save it again just in case it freezes. I had that problem for the first time making the quick Desmos intro video, so hopefully it doesn't happen again. What do I need to change? I need to change my target value right here, and that is it. Oh, and that's the number we got. Yeah, so there you go. It's that simple. I'm just going to discuss this one a little bit. So if we, what is this? This is about comparing the rule of 70 to finding the exact value the good old-fashioned way. Well, and what we see here is that if I calculate A and R, well, I don't have to calculate it, I'm given A. If I use the rainbow rule method, right, I don't even have to go so far as the rainbow rule, right? I'm setting up C times 1/2 to the T equals 1/2 of C. Well, my C's cancel. What power do I have to put 1/2 to get 1/2? T, the half-life, right? T 1/2 is 1. Clearly, right? What power do I have to put 1/2 to get 1/2? 1. Now let's look at the rule of 70 down here. This is not 1. And that's how the rule of 70 goes. Okay, so let's look down here. So tritium, known as heavy hydrogen, it has a decay rate of roughly 0.55 per year. So that's little r, not big R, remember that. We can use the rule of 70 here, and it looks like this. 70 divided by 5.5. You know, just write that as a percent. 70 divided by that number will be a good approximation of your half-life. But we can also do it the regular way, right? Natural log of 1/2 divided by natural log of A gets you the half-life exactly every day, all the time. And A, of course, is 1 minus R, and that's going to be 0.945. But don't take my word for it. Let's use the Desmos calculator. Whoa. All right, give me another save there. Ooh, Ooh, it keeps doing it to me. Okay, there we go. We're going to use a different formula for A now, right? Because I want 1 minus um, little r there. There we go. Well, it thinks r is a variable, so I got to fix that, right? So I can just come down here and tell it what r is. R is the same thing as 0.055, and it immediately knows what A is. There you go. Right there, there's A. And it immediately plots my cat again. I've filled out the values of my formula. There's my cat. We can even tell when it equals 100. Or what do we have it at now? Y equals 71. Yeah, we could solve for any sort of value. What was the value we wanted to solve for? Oh, we want to know the half-life. Okay. Well, let's look up here. Here's our solver, right? This gives us a particular value of t, right? Well, we can actually modify this a little bit, right? Because we don't even need to know what c is in this problem, right? Because we know that whatever that comes out for, we're solving for when it's half of what we started with. So the target divided by the initial value is 1/2. That's what 1/2 of what we started with is, right? So that number is always going to reduce to 1/2, and it spits out our answer just like that. It's that simple. I keep saying that, and I don't know why. It's just popping into my head right now. Um, Give me some feedback about this method. I think it's pretty straightforward. But I've been interacting with computers for a long time now, and sometimes my impression of that is false. So just let me know how these go. Um, so I'm going to let you follow my work on the posted solution here, but the idea here is that we're given a cat. We still have to find A. We still have to find A given the half-life. We're given our C. I mean, this is just the caffeine problem with different numbers, right? Alrighty. So let's switch over to our Desmos calculator, our quick formula calculator. So we'll have to make a few modifications, right? My C is 10 grams. My target value is 2,000. My A, we're going to switch this to the growth formula. So parentheses 2, close parentheses. It just fills in that second parentheses for you. It's so nice that way. We're doing this in months, so that's going to be a parentheses 1/3. Use more parentheses than you need. Just makes it clear. And look how easy that is to read. It's almost like you wrote it by hand. Is that all we need? Is that all we need? You know, we don't even need this much. I could set t to be 3, and why don't I just call this cap t, right? Capital T for the half-lives. Oh, it gets the same number. Well, it should. All right. So again, we can solve this sucker graphically. Click on that point. It says 22.932 months, right? Yeah. Well, let's also do it the formula method, right? So our target value was 2,000. That's when is it going to be 2,000 grams, right? And now we're going to move back to our formula where I divide by cap C there. And we get the exact same answer, right? Less a rounding error or two, right? And that's how that goes. Again, trying to make these shorter. All right. This is another one, right? Exact same approach. In fact, what I'd like you guys to do is see if you can make your own Desmos quick formula calculator. You could have other things in it, like a slope calculator. um, other things like that, right? Um, so if you follow this example and if you follow this work when I post the key, and I believe you can get all the way through there, especially if you follow how I did it in the Desmos calculator. Little linear equations review. So you see here, I've used the slope formula. I've labeled my x or y2, y1s, x2, x2, x1s. Here's the slope I get. Plug it into my point slope form, and there's my answer for that. Now, a couple people came up with sort of a combination of exponentials and a constant, constant like a number. So we had like a 4 minus a cat. You can play in Desmos and set those parameters up, but it's a little beyond the scope of this course. So the conclusion I wanted you to draw here was that, hey, wait a minute. We learned that exponents never hit 0. And so we can't have a y value of 0 there. So the answer for that was can't do it, I'm done. And also this creative answer where you play with Desmos till you get your parameters correct. I'm happy with both of those answers. All right, that's our quiz 7 video. I hope you guys enjoyed it, and we'll keep playing with Desmos. Enjoy your evening.